Jack. If you're happy, then we might move ahead to Cerabyte in that case. And I see Stefan's all ready and raring to go, and I know that Martin's on the call as well. So, hello, both of
Yes.
you.
Hello there.
So, hi, we've got and the last but not least, over to you for the last, 35 minutes, 20 minutes of a presentation, and then we'll have a chat afterwards as we have with everybody else. Before we do though, I didn't invite you all to give Jack a round of applause, so please do. And then we can move to Cerabyte. So thank you very much, Stefan and Martin. I'll leave you to take the floor.
Thank you very much, Sarah. Deeply appreciate it. So we got a few slides and very much looking forward to the discussion following. To kick us off, we have this fundamental problem in the world of digital data storage that over the years we've been able to increase capacity dramatically as well as speed. And access time, but it has gone at the expense of the longevity of the media life. And with that, we have gone from, call it a 5,000 year plus media life to less than 5 year media life. And that is creating us problems. And I will be happy to extend on that. And as Windsurf has most recently also reminded us, being the father of the internet, he knows what comes next after the world's gone digital. He's saying that history will only exist if we make sure it does. And I think that is a very important part, which suggests that there is an active part on everyone's action item list to assure that we will preserve our history for the future. When we look into the data storage challenges, I'm sure that several of these items will resonate with lots of you, is that typically budgets are within a planning horizon of years with a mandate to retain data for either decades, centuries, or in many cases indefinite, which creates a financial problem eventually. We also have the challenge that you get digital data storage to be either fast and expensive or inexpensive and slow. And with regards to today's data storage technologies, we have another challenge that because they experience bit rot, whether it's electric charge based or whether it's magnetic based storage technologies, which will force us to periodically check if the data we've written is actually still there, or it's referred to as fixity checks. Due to the limited life of the media itself, we also see that that is causing extra churn. And we've actually heard from a number of people within the digital preservation community that both fixity checks as well as migrations are reaching breakpoints. And Carl Watts wrote a wonderful article, Carl Watts from the Library of Congress, on the hamster wheel of migration and all of the infrastructure it takes in order to forward propagate digital data. Another challenge in data storage is the sustainability considerations, as well as whether it's future proof, and that is the question of, can you, independent of the vendor that sold you the technology, at some point in the future retrieve the information that you've stored, which is another very important point, next to also meeting all the sustainability requirements today and in the future. So with that, we ideally actually need something new, a new tool in the data storage toolbox that allows us to have permanence. So in an ideal world, I'm sure you will all agree with that, is after you've written the data to the digital storage medium, you ideally don't want to have to touch it again, because any touch will ultimately cost energy and money. And it should be low cost, that's a given. Furthermore, that new storage tier needs to ideally provide, I would say, reasonably fast access and high write and read bandwidth in conjunction with large capacity that would come along with the necessity of low cost. Ideally, that new storage should also have no bit rot and not require any particular replacement cycle in order to realize the permanent storage that does not require any maintenance or migration. And the media itself should ideally be recyclable. And in order to achieve the future-proofness, we want to have ideally an open framework that allows the user to access the data and acquire the rights and the ability to access the data at any point in the future, independent of the vendor. So at Cerabyte, we've thought about how we can deliver on all of these requirements and solutions in order to address that long-term digital data storage. And we've concluded that we need to have a new storage mechanism in order to store the data. And we do this with what we call inorganic bits. You can think of this as a ceramic nanolayer on an ultra-thin flexible glass sheet that is like a ceramic punch card at nanoscale, which is storing the data in inorganic bits, providing for digital unlimited life. In order to get high throughput, we are storing the data in data matrices that allows us to write them quickly as well to retrieve them quickly. And with that, the bits can scale down to a few nanometers, which allows us to deliver ultra high density as well. And the easiest way to achieve low-cost media and manufacturing is to leverage existing industries, which we do through the thin film display glass industry. This is a one-page overview on how Cerabyte technology works. We write millions of bits with the use of a digital mirror device and a femtosecond laser to impose those matrices onto the data carrier. We store hundreds of these sheets that we're using to store the data in LTO form factor cartridges. And with that, we can then store thousands of cartridges within a data center rack form factor that allows us to pack them as dense as we can, reusing existing infrastructure for the library automation. Through a mechanism of accessing the sheets quickly, as illustrated in the third column here, we can achieve not only high bandwidth, but also fast random access of less than 10 seconds. And through the use of megapixel image sensors and microscope optics, we can acquire millions of pixels in one shot that allows us to mirror gigabytes per second of write speed in conjunction with also being able to read at gigabytes per second. What I wanted to show you a little bit is our progress from our checkpoint about a year ago when we introduced Cerabyte with regard to its latest offering. And I hope the audio translates. Can you hear audio?
Can't hear any audio, actually, no.
Hang on one second. Let me stop the share and reshare.
Yeah, there's a little button you need to, or a little checkbox to tick.
Yep, exactly. Share sound. Let's try to do this one more time. Okay. I hope it works now.
Off the shelf wasn't enough.
Yes.
Yes? Okay. Here we go.
Cerabyte's very first working prototype was built from standard components, just to prove that the technology was possible and to show how it could fit into today's data center infrastructure. But off the shelf wasn't enough. To reach our vision, we had to design key components ourselves so they worked together seamlessly. We also advanced the storage medium itself, ultra-thin, flexible glass, higher density, easier handling, and more data packed into every cartridge. What started as a 2 cubic meter, 1 ton laser experiment shrank to fit into a 19-inch rack unit and is now the size of a shoebox. We write much smaller structures, thus increasing the aerial data density. Constant progress in precision of writing led to a better image recognition with a high signal-to-noise ratio, making reading faster. Our own optics allow us to acquire images of larger areas in a single capture, and our evolved data matrix features advanced error correction, protecting against various failure modes for maximum reliability. From bulky beginnings to breakthrough innovation, Cerabyte preserves humanity's data for centuries to come and redefines storage built for the age of AI, high performance, cost-effective, and sustainable.
So that was a quick update on the progress we've made since about a year ago. And just to recap also the characteristics of the media make it an ideal digital preservation media, as it is tolerant to be stored at either very high as well as very low data temperatures. And it is moisture and flood proof. It's corrosion resistant and is not harmed by radiation, as well as it is EMP proof. And we even assured through testing that it's saltwater resistant. The only thing that you shouldn't do is expose it to mechanical impact, as it is glass and that would destroy it. It is providing energy-free retention, as you don't need any air conditioning, for example, to require any particular environmental conditions for temperature or humidity, and you don't need to read the data and rewrite it, as it is once written, can be read forever. With that, it is a write once media and has an ability also to provide a solution for immutable records. And with that, of course, it is also cyber secure safe. With no media degradation, we don't require any migration into future point. And because we also don't have any bit rot, we don't require any periodic fixity checks either. At the end of the life, you can simply recycle it, as it is 100% glass. And as it is made from sand, we have abundant raw materials. We don't even have the limitations that you would have for silicon manufacturing, but you can broadly use the sand available to make glass. And we don't have any rare earth metals and no lead in the process itself. One of our early engagement partners, which is CERN Open Lab, and they are presented the outcome of the initial assessment they have taken, as they have been spending years of scouting for breakthrough media technologies and felt that ceramic is emerging as the promising candidate to have useful I/O and a commercial product within a 10-year horizon. We are working with them on the write read reliability, as well as codecs and error correction, open self-describing formats, and are writing and reading CERN data in the plan for 2026. We've also engaged in other events. At OCP in 2025 at the global event, we provided giveaway samples that you can see on the left side here, which were written with the US Constitution and could be read with just a portable microscope that will cost you about $300, and a smartphone used as a QR decoder. This special demo yielded us great interest and took us also to the point where the US Library of Congress actually decided to include one of those samples that you see on the left side in the 250-year anniversary time capsule for the US anniversary. We are now at a point after development that we are ready to engage with customers for pilots that can be scaled to funding, starting with writing gigabytes of data on Cerabyte media, scaling it to terabytes of data that can be read remote, ultimately also an on-prem library module that is allowing for readback of a single cartridge all the way into an on-prem read library. And ultimately, we expect that we can, within a 2-year horizon, also achieve a writer and reader system on-prem as an engagement for pilots. And we look forward to explore with those that are interested to test this new technology and participate in shaping how it will evolve going forward. And that is with my summary slide. Cerabyte is a future-proof, sustainable, permanent, low-cost technology that has fast write and read, as well as random access to the tune of seconds of access time. And with that, I'll be happy to opening for questions.
Oh, thanks, Stefan. Thanks for bearing with us and getting the audio working on the video. That was really helpful. There's been a couple of questions and responses in the chat. I won't say from the usual suspects, but from the usual suspects. So Paul has weighed in. I think his first question you probably touched on. He said, "How sensitive is the data matrix to physical damage?" Well, I think you talked about the physical shock of the glass, but he asked a question that I suspect a lot of people may think about: can the data be rewritten? Or if you're making migration copies, or are you basically have to sort of create a whole new tile, a whole new ceramic slide each time?
Yes, so the media does not allow for a rewrite. It's a write once media. So you can either, in case of where you have GDPR, for example, where you also may be forced to delete data, right? You would then have to migrate the data that is still valid onto a new media, and you were to then recycle the old media.
Okay. And just skip out. I mean, there's some other things from Paul that we can perhaps pick up on, but I'm just going to jump ahead to Anne Koenig's question, where she says, "How are the data encoded?" I guess on the I forgot what you called them, the ceramic tiles, the glass plates.
Yes.
Sorry
Yes.
if I'm using the wrong terminology.
No, it's glass sheets. Yes.
Are there metadata included?
Yes. So we have two paths for the codec. One path is that it is optimized for longevity, and that would be using basically QR codes wrapped with erasure coding around it. So that's one path where you can say both the QR codes as well as the erasure coding is already an ISO standard, right? That allows you for a simple way to retrieve the data. And the second path that we have is for a high density and media optimized codec that we intend to basically license with the customer acquiring the media and writing the data onto the Cerabyte media. They will have a license to the codec in order to read the data back, right? So it's a unique business model as we incur the vast majority of our cost actually at the time of media acquisition and writing. So we can kind of like include the ability to read it, right, for free if you want so. And to the question of are there metadata included? Yes, there's metadata included to the tune that if you were, for example, to lose the library and the metadata that's stored in the library, you can rebuild it by reading all of the metadata on the media in order to allow you to rebuild, for example, indices and higher level metadata stores.
Thanks, Stefan. I think Paul has made a related comment. Is the metadata in a sort of a proprietary format or something that's particular to Cerabyte, or is it in a sort of one of the open standards that we might be able to sort of recognize?
It's in the open standards. That's why I was saying that whether you go with the QR code erasure coding approach, right, or the optimized codec, in both cases, we basically make those available to customers so they can read it independent of us, right? They have both the capability as well as the license to read.
Okay, he's asking about open sourcing the technology, but you can answer that if you like.
Yeah, there's actually an effort right now underway within a working group called LAST. Happy to send some follow-up information on that, which is exactly intending to build an open framework for long-term data storage, and there the codecs will be open sourced. We want to make sure that's why I was saying that the codec for longevity, right, that will be open sourced. The codec for the Cerabyte optimized high density version, for that will provide a license to read, right, at the time of the acquisition of the media and the writing.
Okay. And I think that picked up Anne's question as well, didn't it? I'm just going to go back to something that Paul was. He talked about, the media, and then he said, what about the longevity of the read-write mechanisms? And I think in a way you answered that when you used the model of the cheap microscope and a
Mhm.
phone or a cheap. But my question would be kind of related to that, which is that, I mean, those scanning technologies and resolution are going to improve over time.
Yes.
So what's your thinking about that? Are your current glass plates, are they good? Are you guaranteeing sort of like backwards compatibility? Because I'm assuming in like 50 or 100 years time, I could write a lot more data to the same piece of glass. But perhaps I'm
Yeah.
wrong about that.
So as long as you stay within the same domain, it will be backwards compatible, right? Because you can always read larger objects, right, with finer tools if you want so. If we go from the optical domain into the particle beam domain, we'll have to see to what extent we can provide backwards compatibility. But within the optical domain, it'll be basically by the sheer fact that you can always acquire an optical image, right? Go forward. It is effectively backwards compatible.
Okay. And in terms of sort of dragging it back to the procurement theme, so where do you see the sort of, I guess, your fit within the procurement process? Is your kind of fundamental point that this is for organizations who want very long-term or permanent retention of data? Or are you saying it's open to sort of more wider use cases?
Yeah, so we start with the organization that have the longest retention horizon for the simple reason as that when you incur all of the cost right up front when you acquire the medium and you write it, the longer you store the data, the better TCO gets, right? So with that, if you have data that you plan to store for 100 years, we can have, even with our first commercial product, we'll be competitive, right, with existing storage technologies. That's simply the starting point, right? As the cost for the technology further advances, right, the retention horizons can get shorter and shorter. And we expect that even data that is intended to be stored for 5, 10, or 15 years eventually can be stored on Cerabyte cost effectively vis-a-vis other technologies.
Okay. And this may be a question that you you can't answer, and I would understand why. Are you in conversations with any of the sort of major digital preservation system vendors to sort of more closely couple your product with theirs, or do you see this as no, we're about storage, and we will talk to anybody that just wants to store data?
We are open to collaborations. We're talking right now with everyone, let's say spanning from, we were just most recently at the US Library Congress, right? We're talking with CERN, right, that have very large open data sets for let's say a data center test use case, all the way into talking with major hyperscalers, I4 hyperscalers, right, as well as solution providers. We are open to anyone that let's say has a major pain point and would like to collaborate in order to help shape this technology, right? We know that at this point in time it is certainly something that is disruptive, right, and fundamentally different from the existing storage technologies. So we certainly have a partner go-to-market approach, and with that we want to leverage what we can.
Okay. And I'm sorry if this relates to the CERN Open Lab paper that you were talking about. Have you done any sort of environmental impact studies to say, well, to store a terabyte on the Cerabyte glass places over 100 years is blah versus storing it in AWS or something like that? Have you done that kind of comparison?
We have done an analysis on how long the media can last under various conditions, right? Yeah. We would have to, and we're open to particular test scenarios. So, for example, the saltwater exposure was something that the intelligence community added to our test list, right? Because they were looking at using that technology in seawater environments, right, in maybe submerged data centers, right, in the ocean. So from that perspective, I'm sure that there are new test methods that people would like to deploy. we found it very interesting that especially electromagnetic pulse testing was ranging at the very top of the list of that many wanted to see, because that would wipe out even no matter what data center, right, you would have. If you have an large enough electromagnetic pulse, right, with all the redundancies, you're risking loss of data.
Okay. I guess just quickly, do you have a view on the kind of classic replication, 3 copies in 2 locations, blah 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 blah. Do you have a view on that? Do you see Cerabyte as having a role to say, actually, with us, you'd only need 1 copy or at most 2 copies, and as long as those are securely stored,
No,
there's
I
savings
think,
there, or you still go
yeah.
for replication, yeah?
Yeah, I think no technology should say you only need 1 copy, because there's always a chance that 1 copy gets wiped out. So you want to have multiple copies, but we can give you those multiple copies at a very affordable cost. That's, I think, the key. You make those sheets low cost enough so that you can say you can have redundancy, regional, right, or worldwide geography. I mean, there are even people that want to put a copy on the moon or on the Mars, right? So depending on what threats you want to defend against, right? I would definitely think that you would want to stick with multiple copy strategies. What we have seen, which is very interesting, is that people want to have especially a local copy. They may have a copy in the cloud, right? But they hope they never have to bring back all of the data out of the cloud, because that would be quite expensive, right? So having a local copy as a complement, right, to the working data set, that's what we've also seen as a consideration, right? So have a local disaster backup, in addition to, of course, you have an offsite copy as well.
Okie doke. I have lots more questions, but they're getting into the realms of science fiction and my enthusiasms for other things, and Sarah's giving me a hard stare. So I think I will, if everyone's agreeable. I can't see many more questions coming in on the chat, so I'm going to pass back to Sarah.
Did you spot Adam's about the GUI? Which is the one
No,
before.
sorry, Adam Harwood. Yeah, he's saying,
Yes,
do you have a
there you
GUI to interact with your data, or is the focus on hardware?
Yeah. So the intention is to dovetail into the existing storage ecosystem. That means that the devices could be, for example, addressed with a block storage protocol that of your choosing, right? And we also see that at the system level, you would have an S3 compatible access, for example. And that's also why we want to partner, right, with the existing software stack vendors, so that we can just add Cerabyte as yet another backend storage media, right, into your existing workflow. We understand we don't want to change people's workflow, and we don't want to change the software stack, because that would be a 10-year plus endeavor.
Okay. Sorry, Adam, for missing that one. Thanks, Sarah, for picking me up on that.
That's okay. Didn't want to miss any. But no, I think we've had a very thorough introduction and a very comprehensive overview of the Cerabyte technology. So thank you very much.